Greetings. I've been set a challenge with my 415 volt power supply. Photonicinduction has challenged me to load this up and keep the voltage above 400 volts whilst on full load. If I manage that, then, well, apparently I'm going to need a magnifying glass. So I've got my magnifier ready, just in case. Before I start, for those who are unfamiliar with UK plugs, normally they'll have a fuse inside the plug. One like this is a 3 or a 5 or a 13, those are the common ones. I've also got a 7 and a 10 amp one here as well, which you won't find very often, but they are about. As you can see, I've fitted the welder with something a little bit higher rated than 13 amps. So let's trace what we've got here. This is the breaker, which feeds that 63 amp socket, which feeds that mains conditioner. The output from the mains conditioner comes through that loop, so I can measure the current, and out through these sockets at the bottom. The right hand one is being used to measure the output voltage with my power analyzer. The left hand one goes around to the welder. The output from the welder, the normal output from the welder, just goes over to there, out of the way. I've got a 415 volt socket on there. That feeds this, which has got a tap, which is measuring the output voltage from there. And before I go any further, this is at 240 volts mains potential. This is, if it was DC, this would be minus 170 volts. This is the other side, this is the output from there. So over the two, you got about 410, 415 volts at a 240 volt input. So that's why I'm measuring on the neutral side. And that's also why I've got the live and neutral connections the wrong way around on the measuring device there as well. I'm using neutral, I'm using the live point as a reference, so that's 240 volts one way, and that's 415 volts. It'll all make sense in a moment. The output from there, we have a two-way adapter because they didn't have a four-way socket. One is measuring that, the other is going along here to this splitter. Earth connections are in parallel, but we have the live output, which is here, which goes out that way into one of those 1000 watt flood lamps, in fact the back 1000 watt flood lamp. The neutral from that then goes to the live of the next 1000 watt flood lamp and back, and the neutral goes down. So the two lights are connected in series. Also, we have this white cable which has a similar arrangement. Where the live comes in, goes out to one of these 2.5 kilowatt Glen fan heaters. Then the neutral comes in from that heater, goes to the live of the next heater. And the neutral from that goes back and flows down. Earths are in parallel. You can see there are no other cables. Let's power it up and see what we get. And first of all, I'm going to knock the fan heaters off, so we're just running with the floodlights. Oh, the other cable, which I didn't mention, coming from the output of my power supply, goes to this dead man switch. If I let go of the button, power goes off. So, breaker on. And there we have a 238 volt input and 407 volts output. Running those two floodlights with just over 200 volts apiece. Back down to here. Ignore L3 by the way, it's off load and is actually there. Let's take a look at the power consumption. And the input is 1.8 kilowatts, 1.9 kVA, and the output is 1.6 kilowatts or 1.6 kVA. Unity power factor because it's a resistive load. Now then, what will happen when I add those two 2.5 kilowatt fan heaters on? See, the input current has now jumped up to 5.1 kilowatts. Now they're not going to draw 5 kilowatts a piece because they're not running at 240 volts a piece. They're running at around about the 200 volts mark. We'll take a look in a second. And the output, 4.7 kilowatts, 4.7 kVA. Again, they're a resistive load, so the power factor is unity. And you can see, just take a look up there. The pilot lights are on. Well, they're on the one anyway. Pilot lights are broken on the other, but they are running. Both of the fan heaters are running. I'll get to demonstrate. If my arm was in the way then, I must apologise, but I'm the cameraman and the actor here, so can't be helped. While I've got my temperature sensor in, let's see how the transformer's doing. It's a bit warm, but it's not too bad. Hold on a second. And considering that's pulling, oops, took that too far. Let's let that start up. Oh, 381 volts. The input voltage has dropped down to 230. The output 380, 381 at 12 amps. With 21 amps coming in. So how can it do that? I mean, this thing's pumping through 5 kilowatts and it's getting warm, but it's not getting too hot. Well, if you've seen one of my other videos where I did a bucking transformer, which was stepping 3 kilowatts of power down from 240 to 220 just using a 225 watt toroidal transformer, you may get an idea of why it's working. What we're doing here is the transformer isn't kicking out 415 volts. The transformer is kicking out about 170. But we're just then adding that to the 230 volts, 240 volts coming in to get our output voltage. And as you'll see, if I demonstrate with this current clamp here, measure on there, you'll just see just to give an idea of accuracy, this is showing 11.1 amps, but it's only a cheap thing anyway, but it's shown within an amp of the output there. Now on the transformer, if I measure here, I'm measuring the input current to the welder itself. Which is lower. Now, even though the output is 21 amps, the transformer is only responsible for 10 amps of that. The rest is coming straight from the mains and just cycling through the secondary and away. The transformer is only transforming the 110 volts, the 170 volt supply. So that is how it works. And I could take that up quite a lot higher, I think, before the overcurrent would kick in. In fact, I do have a spare current clamp. So I'll take this CT here, which is L3, and try not to chew it up against the fan. Oops. I'm doing this. And there we go. I'm not sure exactly how these currents add up. Maybe it's because it's right next to the transformer, you know, because it does seem to vary quite wildly. So I think the transformer is having an effect on the current clamp there, because you can see I can get that up to over 20 amps, and there's no way it's actually drawing that. So it's a bit hard to measure that. What I'd have to do is disconnect, run a long lead away, and measure it away from the transformer where it can't interfere. So that's basically a rubbish response there. But you get the idea. Transformer is now, that's getting a bit hotter now. That's up to 87 degrees. In fact, 92 degrees there. But if it got too hot, the over temperature indicator would kick in on that anyway. So, does it work? Yes, it does. Oh dear. I just realised. I think my mains conditioner has stepped up to the next voltage tap. So we now got 243.8 volts in and 400 volts out. For a total load of 4.9 kilowatts. Out, 5.5 in. I might need that magnifier after all. Thanks for watching. I have it on very good authority that this isn't going to do very much at all. apparently the welder isn't going to be up to the job. I'm going to give it a go anyway. And for good measure, let's give it some lead plates. That was a bit shit. We've popped the element already.